Good afternoon, everyone. I am really happy to welcome you the third event of today here at the Cryosphere Pavilion at COP26. Now, the talk of today is about infrastructure damage and coastal erosion by Hugues Lantuit from the Alfred Wegener Institute. So, please.
Thank you very much, Francois. I'm adjusting the microphone. I will pretend that this is an incredibly well-organized, well-structured, and super masterminded presentation, but it's not. This is something we organize actually quite spontaneously, and you will see that later on. I will be joined on stage, so we will ask someone to help us out putting 3 chairs here so that we can discuss of these issues, and that you can't see it on camera for those of you that are following us on the stream, but that is Maka and Darcy who are standing on the side of the stage here. And really the idea is going to be to reflect on the topic we're going to talk about here, and we might be changing a bit the focus or compared to some of the sessions we had, because we will talk about very practical issues, infrastructure, and not necessarily about COP relevant policy issues in the way we might argue whether we agree on that focus or not, but in the ways they are formatted until now. So these are a very pragmatic presentation. And really what we're going to be looking at is the coast, and we're going to start with infrastructure, but I want to start with something else, because the way we see the Arctic, or at least in the traditional COP narrative, is like this: vast areas that are deserted where the fantastic scientists can go and discover what's out there. But that's not really how it is, because when you think about it, there are actually lots of people living in the Arctic, at the coast, inland, in small communities, in large cities. There is a very large diversity of people from in terms of their origin, their country, the type of cities they live in. This is a map we are producing in the project that I lead, which is called Nunataryuk. Nunataryuk stands for Land Sea in Inuvialuktun. And that map is showing you the distribution of communities in the Arctic. This is a really, really nice map, which is overlaid with permafrost here. And already you can see some quite fascinating trends, very different circles in terms of the sizes. If you look at North America, you will see that you don't have actually a lot of large cities based on permafrost, which might be the case in Russia. So that is going to play a role in the ways that infrastructure and climate change impacts on infrastructure are being dealt with in these kind of different kind of settings. Obviously, there are historical, legal approaches that differ from country to country, but alone that sheer size of the communities that are on permafrost is an important factor. Here, a couple of numbers from a paper we published this year. Well, we realized we didn't know how many people lived on permafrost at the Pan-Arctic level. It was really hard to figure it out, to find numbers, actually. So we just ran an exercise, which was actually quite challenging. You can imagine that the borders of any kind of data set on population that you can find in the Arctic do obviously not match with the permafrost extent, wherever it is defined. So it took us quite a lot of and time and energy to actually find the right information to do that and to understand and quantify how many people. So here's a couple of numbers stemming from that study: 235 airports. This will be very relevant. You will see it for the airport there. Airports are key infrastructure for many communities that are not reachable by road and are right now very strongly impacted by permafrost thaw. 2 million people here. I must say, this number is, we think, one of the best numbers we've been able to put together. But again, this can't be really like exact, because there is so much fluctuation in the kind of data sets you deal with when you're dealing with demographic quantification or studies in the Arctic. A lot of these these settlements that are located in the Arctic regions are actually on permafrost. So more than 50% of these settlements are located on permafrost. This number is probably not true anymore, because the data we relied on was based on the extent from the map on permafrost you've seen earlier, and we've seen that this has shifted dramatically already over the past few years. So a lot of the settlements that were on permafrost are not on permafrost anymore. And this is actually the most important impact. We've seen that even in the far north, you're starting to see impacts, but right there, as long as the permafrost holds together and you build for the permafrost, you might say, and I'm saying between quotation mark, okay, really the difficulty is when you shift from a place, from a situation where it was frozen and it's non-frozen anymore, then you run into major issues for anything built on the permafrost. And the situation of these communities is also very different. Look at that. This is a map of the communities in the Arctic, their size indicated by the bubble, but also in red or blue, the dynamics. Look at North America, for instance, very dynamic, growing communities. Growing communities meaning immediately you can think of a central issue being housing. How do you build housing in a kind of situation where you're shifting from a permafrost to a non-permafrost type of environment? So this is already quite challenging. In Russia, different kind of dynamics where you see most of the smaller communities shrinking and people moving to the very big centers. So in studying that issue in the way we're trying to do that at the circumarctic level, we're seeing a lot of difficulties to put forward some best practices, some best experiences, because you see the diversity that you have in the kind of different settings and different sizes and the different kind of people living in these communities. Now, what we think is that this is going to shrink. So this is the number of people living on permafrost in 2017. I was telling you around 2.2 million people. What we think is that in in about 30 years from now, well, actually 29, if you count that we are in 2021 now, we're going to have that number reduced drastically. What that means also is that we're going to get more than 1 million of people leaving the permafrost area, if you want, not being living on permafrost anymore. And in some places, if you leave what we call bedrock, so hard rock, those effects might be less important. But if you live on permafrost that is ice rich, you can imagine what happens. If you put an ice cube and you put earth on top of it and you just melt that ice cube, the earth is going to subside. That is on top of it. That's what we can expect in places where we have lots of ice in the ground. And that place is the Arctic, and the Arctic permafrost is host not only to communities and to people, but to a lot of infrastructure that is there to sustain some of these communities. But, and I think that was part of the session on justice, or even the session before we heard, to actually extract of a lot of the natural resources that are there in the north and to bring them back to the south. A lot of this infrastructure are, for instance, coming from the Yamal Peninsula. We see that they don't. But what's fascinating here is the number of airports that are mapped on that maps here. And you can imagine that for any kind of agency having to deal with the effects of climate change or permafrost on airports, this is going to be a very big challenge. I want to spend a bit of time on that map. This is a study published by colleagues out of University of Helsinki and Oslo and others, actually. This is showing you something similar with what we saw before. The infrastructure, the communities, so small dots here you see on those insets, the little airplanes that show you actually the location of airports. And what the color map is showing you is the level of hazard that is planned in the future. And that is based on a variety of factors. That is based on the warming of permafrost, but that is also based on the amount of ice in the ground. And that varies quite a bit. And that generally is a challenge, actually, because this kind of modeling approaches, if you look at them, or if you try to see the size of the pixel, it's the one that you see for a usual model, maybe a couple of kilometers. And if you are a community at some point, you're going to be in one point within that pixel, but the whole pixel is going to be incredibly diverse in terms of landscape. And so these kind of efforts are useful in conveying the message to policymakers at the circumarctic level, but they are certainly not applicable for any kind of planning. And there lies actually the main issues in projecting or actually raising awareness about these issues, because you can do that in putting forward data sets like that when you show the impact at the global level, when you start putting numbers on them. but this does not reflect the extreme diversity of situations from one community to the next. So here's some of these findings where they say that 70% of current infrastructure in the permafrost domains are in areas with high potential for thaw of the near surface permafrost. And then that next number is showing you which kind of the proportion of infrastructure that could be affected or impacted by the thaw of permafrost and basically collapse. This is the reality. When I'm not dramatizing the situation, I have a couple of pictures to show you impacts on buildings. A lot of those buildings, for instance, in the Russian Arctic, were inherited from the 1950s. We're seeing a shift in the ways actually buildings are being built, a bit of a convergence actually with North America in terms of construction norms. And this because things are changing so quickly that housing is becoming short in many of those communities. Here, one slide. I have one slide to talk about money figures. This is one paper that is trying to quantify the change in money value in terms of infrastructure maintenance that is going to be linked to permafrost thaw. And that is that last column here showing you the increase of those costs until 2060. 2060 is very soon. It is very soon. We might even me might see it. The 2060, and there see those very substantial increases in terms of cost. For some regions that are particularly sensitive here, that means that it could represent 1% increase of the gross regional product, which is very, very, very substantial. So the question is who pays? And I don't have an answer for you today. I don't think no one does. But what I'm certain is that this is not on the radar of many governmental agencies or even local communities themselves. The other issue in doing all these efforts, and sorry, I'm going to go back to that map here to show you that there are actually very few papers, very few studies trying to do this and trying to quantify that. Why so? Because it's difficult. Because first, we're having challenges in mapping the way permafrost is going to degrade, but also because we don't have basic information of where houses are. Sounds very simple, but if you want to map like damages, you can do that at the scale of a community, go there and do some efforts. But synthesizing that knowledge at the Arctic level is incredibly challenging. So we're trying to devise some methods now to do that. This is a brand new effort, which is based on radar imagery. You don't see the radar imagery, you only see those hexagons and the density of the proportion of the surface that is human built, if you wish, within those polygons. So the darker they are, the more of a human presence there is. That's what's built with radar. And the idea here is to build an algorithm so that you can automatically map infrastructure throughout the coast. I believe the paper is out actually by Annette. That was sponsored by the European Space Agency. So that's a fantastic way to start putting numbers out there, because the thing is that it remains very spectacular at the scale of the community. And that is the main issue, is that those costs are incommensurable. The discrepancy between the costs that are falling upon one community and the actual resources of the community itself, economical resources, is enormous. There is a huge gap here. So you need to show that that gap is real, even at this kind of scales, and what it represents and how much it is. The other thing that makes the thing complex is this, and this is very telling. What we've been seeing since the morning is a lot of graphics showing us where we headed at in terms of numbers, but we haven't seen the permafrost too much. Why haven't we seen the permafrost too much? Because you don't see permafrost, because permafrost is under the surface. So it's really hard to show pictures. We show you beautiful pictures Jens showed earlier of this thawing permafrost. Gustav showed the same one with that exposure ice face, but this is more the exception than the rule. When you are in the field, you will see like the tundra. The first time I went there, I actually thought that was like Ireland, like I could play rugby on it. It looked like this beautiful green area. This is not actually how it is. So you don't see the permafrost. While underneath, the permafrost is very diverse. Look at this core here. This was taken on Lantuit in northern Quebec. And I'm going to come back to this community later on. Look, we call that somewhat, you could call that a reticulate type of cryostratigraphy in that core. that can be also very different. It depends. Like there's different ways to characterize it. It can be very complex. So you can have shapes like this. You can have full amount of ice, and you can go 2 meters next to it, and you will have a core that is going to be only sediment or only ice. And that is obviously extremely challenging when you're building anything on a community. And there comes a challenge in binding those projections we're trying to do, or the models that we build that are built most of the time for these very large scales or global scales with what's happening on the ground in a community. So I'm going to show you a couple of examples of what we do, and trying to see how we can assess the issues linked to infrastructure, and also propose some answers, and develop these answers together with community members. This is Kayanak, so that's on the west coast of Greenland here. A community that looked like this in 1961, so built a bit of a fan here, and with very few houses in 1961, but you can see a planned structure with very straight streets here, very close to the coast, obviously to access resources that are in the coastal area. This is now how it looks, and so you see it had expanded much, and this map was made to characterize with those very simple colors to understand, and that was developed in cooperation with the community to develop planning tools to actually assess the state of this building. We're only talking about the state, we're not talking about the future state. And already there, you can see that in 2018, an overwhelming part of those buildings was in a bad condition. I'm going to tell you a little secret. This is not the only place in the Arctic. And if you go abroad, if you go to Alaska, if you go to Canada, if you go to Russia, even in some parts of northern Norway, you will see some damages to the buildings. Bad construction, maybe, cheap material, maybe, but permafrost is and remains a challenge. And it is even more of a challenge now that permafrost is warming. Look at this inside of buildings here. Things are cracking. That's related to that thing. That results in bad insulation of the buildings. That also results in very bad indoor air quality. So a lot of detrimental health impacts that are indirectly, but you can see here the logic of the impact of permafrost on this health component. So very drastic. Here are some other examples, again, from Kayanak. Look at this here. People have tried to raise the building here, to put some pieces of wood here to fix the issues. I have many of these pictures trying to find some ad hoc solution, because the planning, the shipping of repair material takes a very long time. That relates to the what we talked about, the supply of smaller communities, whether they are in Alaska, in Canada, or England, is a challenge, and it's a challenge to solve this kind of issue. So here you go. What Thomas, and that's data from Thomas Ingemann Nielsen, my colleague from Copenhagen. Here, 40% of the buildings in that community would be deemed uninhabitable in our standards, if you want, in more southern latitudes. I have 2 slides to tell you that everything I'm talking about sounds like I'm very focused on the Arctic, but these problems are also visible in mountains, and we are in a global here conference, so it's important to talk about these issues. There is actually a poster behind you on the impact on permafrost and rockfords. This is a rockfall that is in the Alps, and the succession of lines on the top right picture here is showing you the different kind of events that occurred. These events are increasing in frequency now because these rockfalls that are happening actually on the shoulders of the summer season, often at the beginning or at the end here, are increasing. That frequency is increasing because of the warmer temperature. Because if you wish, permafrost is holding things together, and with permafrost, so that is contributing to make it more rockfall prone. And we see a lot of these rockfalls happening there. And we have similar issues on the Tibet plateau. Here, that beautiful picture of the Qinghai Tibet railway. This is a railway that was built 10 to 15 years ago. I can't tell you the exact year. On one of the most extensive permafrost areas in the world, the Tibet plateau. It's very, very large, substantial amount of permafrost there, and already at that location you can see some damages. This was the state-of-the-art construction on permafrost, one of the probably the largest construction project on permafrost over the last years. And already you see some cracks located at the bottom of the slope of that typical embankment that is created to protect the underlying permafrost from the thawing effect on the black asphalt, or in that case, of the railway. And that is confirmed by these techniques that we use quite now often to detect subsidence. It's so-called DINSAR. It's simply taking two radar imagery, and with that thing, for instance, you can detect earthquakes movements. That's not what we're doing here. We're using that technique actually to look at subsidence related to the melting of the ice in your permafrost and the fact that the surface subsides. And here, you need to believe me, anything that is along that line here, this is the railway, and anything that is turning towards red means there is more subsidence, and that subsidence here is reaching, in some cases, 20 millimeters per year. This is very substantial. Interesting, though, if you look at that, it's not a spatially homogeneous phenomenon. It changes in space, and hence the challenge for planners, repairs, maintenance, etc., etc. Last example, that's from Ilulissat in Greenland. Again, here, quite a bit of permafrost. Theoretically, that should be a bedrock type of coast and should be limited in terms of impact. But we see in the village, actually, that a lot of areas shown here in red are experiencing some negative vertical displacement, meaning that thawing permafrost is leading to impacts of these buildings. The building colors here, it's a bit the same. So you got some building colors showing you when they are actually more threatened or not in a good state. Another example, I really like that one. This is a very long-term collaboration with the community between the researchers and the research engineers at Université Laval. This data was sent to me by Michel Allard and the community of Saluit in assessing and co-developing strategies to answer the most pressing need, which is to create or build some new housing that should potentially outlive the 30 years that is typically planned in this kind of projects. And this is very challenging because this is a community where the underground is also very diverse and very diverse in space at resolution that are very hardly detectable by the models that we usually use. If you look at that map, that was a map that was developed together with the community. Look at these different colors. This is a very simple color coding here with red, green, and yellow to show which areas are better for building. That had resulted, together with the community, in the change of the planning here, where some places are now meant to be located in areas that are more green, if you want, and were originally maybe closer to the community, but an area that was red and therefore more prone to hazard than other areas. So a very useful way to actually a very good example of collaboration with the community to find solutions. So I have this complicated slide, the one with the most text here, but what I want to show here is that the models that we usually talked about, and we talked about since this morning, are the one that you see on the top right here, land surface models, if you wish. Those are operating over a fairly long time scale and over fairly large areas. They can't have the resolution that we need at the local scales. Models for local scale could exist. In our case, there are not many of them for permafrost applications, but they could exist. But then they are very limited in size. And what is interesting is actually for us to connect those climate projections to actually what's happening at the local level. So there is a new generation of models being created, or hybrid, if you want, or trying different kind of new connections between those different kind of model families to try to devise strategies to do that. Let me give you a cool example from the Dalton Highway in Alaska. Here, typical road being done the permafrost. You see that island type, like green grass here, and then on top of it, that tough, thick gravel pad on which the road is being built. That gravel pad is basically a fence that you build in a landscape, and that fence is doing what? Well, it's catching the snow that is being pushed by the wind. And that snow accumulating, that has a considerable impact on the ground thermal regime. So now I'm going to show you what it does, the snow over time and the accumulation of water. This is our road. So you need to believe me, that little diagram on top, it's showing you the end of winter and the end of summer condition. On the left is showing you this is the temperature scale bar. I'm gonna show you now over the next years how it's gonna look through our model at these very local conditions. Look at that, your road is on the top left here, that's the thing, that's your little gravel pad, okay? So it's already kind of warmer in the at the end of the summer. You see those red colors. Now if we look at it and in time, this is how it's gonna look in 2020. The starting data is in 2000. You can see that the end of summer impact is much, much larger. But actually, you can also see in winter that snow that is being accumulated, and I'm going to leave the microphone for a second to show you. And that snow that is on the side of that embankment is going to contribute to have an effect warming the ground. So snow is actually warming the ground, which is kind of counterintuitive at first when you first know the issue, but it does. And it warms up the thing, and then over a longer period of time, this is what you end up with. And then ultimately, your underground does not recover, and you end up with such situation. Again, what's going to happen there, it's going to be maybe different 20 meters away. And that's going to be your issue. And hence all the pictures we see from rolling roads everywhere in permafrost regions, because you have so much spatial variability. So now I want to talk about one issue that is in the title of this talk is coastal erosion. While I was borrowing a lot of the slides from about infrastructure from my colleagues, because this is not necessarily my specialty. Coastal erosion is the topic I'm focusing on, and I want to report on current dynamics. So we hear a lot of reports and seen some pictures of villages falling into the sea. But until the late 2000, it was really hard to actually detect a signal, even with the very little data we had at the circumarctic level. So for the entire Arctic, including Russia, Canada, Alaska, a significant signal of erosion increasing. There were some dramatic years and storm surges, but there was no real indication in the data that we could see that it was increasing. But that changed quite recently. So if you look at this situation, this is a place called Stokes Point, where there is a landing strip that is essential for the area. This is Anna, who was my PhD student. We're standing next to that cliff, and you can see the amount of ice in the cliff. And the sea is really knocking into that cliff. Or a little surge, a little elevation of the water level means that permafrost, which actually binds everything together, it's like the cement of that coast, is going to thaw immediately, and that's going to result in the release of all that sediment. Between the 1955 and 1974, erosion there was 0.4 meters a year. This is about the average rate of erosion for the entire Arctic, actually for permafrost coast, which is already fairly high. Imagine any place in Europe or in southern United States where you see that kind of erosion. So people would panic, but this is actually quite standard in the Arctic to this kind of rate, even though we have only 4 months in the summer generally where there is no sea ice. Only 4 months. The rest of the year, the coast is protected. And that's mostly because we have this kind of coasts, which are very easy to erode once you get the wave to reach them. So now I end up with a suspense. So you will see the data coming up. So this is what we had in 1974, 1976. Now you guess from my slide that those bars are going to climb. And this is when I kept those low, because already there was a doubling of the rate of erosion in a matter of decades. This is what we got between 1966 and 2007. We're starting to have 2 meters a year. 2 meters of coast disappearing. 200, that's a lot. That's a lot of surface that is disappearing. And this is what we know happened until 2015. We now have at that location 8.8 meters a year. And I'm telling you, this is actually not the most recent data. We know that the rates are actually higher now, getting close to 10 meters a year. This is very substantial. And this has dramatic impacts on the infrastructure that is located there. Now I'm showing you this is not obviously everywhere the same in the Arctic. This is a map of the Arctic showing you the strength of erosion from green to red here. So from 0, if you wish, to our stable or grading coast to 2.2 and 12 meters a year. And this is how the data looks like. What is striking here is that it is extremely heterogeneous. So that makes it again very challenging to look at. And until very recently, until this year actually, we had no model whatsoever that could model coastal erosion over the 100 years to come. So this is very new. We can actually start to look at it. I'm not going to show it here, and that's the goal, to show it in the last session this year, this evening, because there are numbers on carbon. But believe me, those numbers are from a publication from 2012 that is based from data running until 2000. And when you think back of the bars I've been showing you, you can imagine that anything you've seen here has changed drastically. In the meantime, we're at 2007, 2012. That are years with very little sea ice that allowed a lot more storms with a lot more fetch to actually hit those coasts. What does that mean? Well, we're trying to assess that in doing it locally, but this is extremely time consuming, or it was until recently. And we're hoping to take advantage of new approaches, including Google Earth Engine, to do that. But before, what you had to do is to go back to archive, find a lot of air photos, and to compare those air photos to modern satellite images. Whenever we can, we could actually talk to the community to know that. But there is not only along the entire coast traditional fishing camps. So you can talk, for instance, here, we talk a lot to Danny C. Gordon, who's from Aklavik, who has a camp at a place that is called, it's west of Well Bay here. This is pretty much the only remaining camp along the entire coast west of Shingle Point that is being used on a regular basis. So the knowledge that is being gained is actually mostly the one from Danny that has been doing there. Younger people tend to go less to this kind of camps nowadays, or not wanting to travel. Gas is also very expensive to get at, so that makes it very challenging to actually rely on the knowledge of people there, except, of course, that we can relate on whole histories that has been reported. So we do these kind of things to assess that. This is our baseline, and with that kind of baseline, we can do a look at the impacts. The impacts are very substantial. Here, I'll show you a picture from Shishmaref. This is in Alaska. This is a very well-known picture, but this is to show you what concretely that means for communities that are located at the coast. These are substantial costs that are very hard to actually cover for one single community with the resources it has. It's not only infrastructure and buildings, it's also cultural sites. Here in this study, what we try to do together with Richard Gordon, with the chief ranger from Nunataryuk on the northern coast of the Yukon, is to reconstruct cultural sites, graves, places of celebration, fishing camps, harvesting camps, etc., that are used traditionally by the Inuvialuit, to see how many of these sites are under threat and what to do about them. And this is very difficult because there's quite a lot of them. There are some that are inherited from the early settlers, if you want, like the Hudson's Bay Company Post. And then you have some traditional cabins that are being used by some people, some graves here, etc., etc. And you see the numbers here, lots of these features that are being threatened by erosion. What do we do about it? What do we, the Inuvialuit, want to do about it? It's a very big challenge to understand what to do with those kind of features. Do we want to move them? Do we want to preserve, document them? This is a challenge for cultural history also. So here are a couple of zooms on that cabins here. This is in blue and red, you see the coastlines in the past, in the 50s and 70s. In black, this is the coastline in 2011, and you can see that a lot of houses that were mapped, so those are the triangles and the graves with the cross, are actually gone already. So they were eaten by the sea between the 50s and the 70s. And then what we've mapped with the dashed line is a rough projected shoreline for the future. And you can see again that a lot of those features are under threat and will not be preserved. So a very difficult challenge in terms of management. I'm going to pass quickly here. This is, you can check it out in Anna's paper. Again, this is a place that is a very much used fishing camp, Shingle Point. And here the main challenge is actually storm surges, because this is a very low elevation camp, and storm surges in the past have been increasing both in height and in frequency, and this is a major threat for the area and for that fishing camp. Last but not least, a landing strip. This is again our shoreline, so like the purple and the blue in the 50s and 70s. Then our current shoreline, so 2011, and then look at those two landing strips. Those landing strips were there to supplies the dew line site that I think pretty much everyone knows in the Arctic, the distant early warning site, radar site set up by the US to protect from the Soviet in the 50s and 60s. And those landing strips are still being used intensively to supply some fishing camps or research or any kind of activity in the area. They are disappearing fast, and that raises issues because you can't land the same kind of airplanes. You have to have very small bush planes to use that kind of places. I'm going back to Tuktoyaktuk. That was a picture I had in the beginning. Here, that community is very well known for the spectacular threats it experiences from coastal erosion. But here, I want to focus on another issue I touched upon is storm surge. If you look at that community, it's very low lying. And any kind of surge of the magnitude we can expect with it for the 21st century, especially with mean sea level rise rising very quickly, would result in the flooding on a very substantial part of the community. So relocation is definitely due to erosion, but not only storm surges. And I was talking to Mark briefly beforehand. Storm surges are definitely one of the main issues for coastal communities in the Arctic. Here I have one thing that we did in our project, and I think is very interesting. It's because we had the chance to work with communities and people throughout the Arctic. And usually when you have such project, you need to work locally. And in doing so, you are actually looking at the issue from one community perspective, which is the way to do. But we were such a large project that we could have that approach at several communities. And that is really, really nice because you can see what the concerns are of the people in these different communities, how they are articulated and how they differ and what it is linked to. So we asked those people, over the past 10 years, would you say that the thawing of permafrost has led to positive, negative change, or no? And look at the sensitivity. If you are in actually Northwest North America, so Aklavik here, the negative impacts are particularly felt. And then if you go to other places like Longyearbyen on Svalbard or on Greenland, Kekertasuaq, that's not going to be that strong. And there is a simple explanation for that, is that where you are in Aklavik, around there, people use the land quite extensively. Let's say first, they do so in Kekertasuaq as well. But the land in Aklavik is very much prone to permafrost subsidence. There is a lot of ice in the ground. And that's not necessarily the case in Greenland, and even less the case in Longyearbyen. Then we look at the observed changes in the environment. And again, here it's fascinating because that was the same question to communities of a similar kind of size. And the way they see that, obviously, we try to relate those issues to permafrost, though, but they are seen very differently in different kind of community. So that paper is coming out soon. I think it actually came out this week, the one from Lenesa, trying to look at that with community partnership and participation of many community members from these three different communities. So this is the way we do things. We just at the start, I must say that we are a European project made of a lot of European young scientists that are learning how to do research in the Arctic. And we've heard the experience, I think, over the last 2 sessions on how to do research in co-designing, co-developing, finding solutions, listening, being humble. I think that's what we're trying to do. It's a double challenge because a lot of the people that we have in our project have never lived in an Arctic country. A lot of them live, let's say, in Germany, in Italy, in Portugal. But I think this is fantastic. And it's also fantastic for the communities to have people maybe that are coming from different kind of countries to tell that story. So there is, I think, a win-win situation here if we manage to find a common voice for devising those projects. And I'm very hopeful we will do so. So my citation to finish that presentation, that trust has to be earned and should come only after the passage of time. Putting out like great principles on how to partner to communities is a good thing and it's necessary. But ultimately, the trust in each other is like it comes through time. And it comes through being able to engage with people on a regular basis and going that every year to establish that partnership. And this is starting to pay out for us because we are respected and understood. And we understand actually people on site or try to, in the most humble way, we can do that. I finished with giving a little advertising for a product we're putting out. It's the Arctic Permafrost Atlas. You can Google it. There is a Twitter from Levi Westerveld, who is leading that project for us, or go on the Nunataryuk website. I'm just saying it because there are going to be very cool graphics in it. If I manage to press on my button, Niklas. Yeah, here you go. Like this, showing you the increase in permafrost temperatures in different kind of communities in the Arctic, and showing you the size of the communities that are being expacted here. So we have a great group of cartographers showing that in an innovative way. Go check out the Twitter from Levi because he's teasing a lot of these graphics coming out progressively. This is a map of the Antarctic, for instance. It's beautiful, showing you like permafrost stations located on permafrost and the current state of permafrost temperature there. And that's it. And I seriously hope you're going to go on Facebook at the end of that talk to like us. This is my only request from all of you guys. Thank you. So, Mac, promise we will do that on the free. So I don't know if you still have time or if you have to leave. You have a bit of time. So we would go there. And Darcy has disappeared. I know she has not disappeared. So she's over there. So we try to put 3 chairs on stage. Now? Oh, fantastic. So thanks a lot for, actually, I probably need a headset to listen to what you guys are saying, no? Yeah, you can grab one behind Gustav, thanks. So thanks a lot for doing that. I'm going to give the microphone first to Maka because Darcy, we heard you quite a bit today on different kind of issues. Maka, you said you're coming from a coastal community, Darcy from a more inland community, and this is what basically how we framed what we talk about here. I gave you the researcher perspective, saying the southern researcher, the French, German researcher perspective. And I think you told me that the things are experienced very differently in southeastern Alaska, especially because the notion of permafrost is somewhat different here, but being a coastal community, you're experiencing some of the issues we've been seeing in my slides.
Yeah. Is it possible for someone on the computers to pull up one of the maps that our friend here had? Oh yeah, can you do any of the maps that show Alaska? Just any of them that we can show the state of Alaska. Just the state. So the map, the state of Alaska.
The Arctic or?
Yeah, any of the Arctic circles. Hi everyone. You could go to the next one. Maybe.
Okay, fine.
Yeah, so we can just see the state. My name is Mark Mantrupaki and Kitliyate. I'm Tlingit and Mohawk, and I grew up in Yakutat, Alaska, which is a coastal community and the northwest coast, the northernmost part of the northwest coast. My people were originally Athabaskan, and over 1,000 years ago, we migrated down the Copper River and over a glacier and settled in Yakutat. That's perfect. So almost what's funny is he's pointing exactly where my village is. And
Maybe if I need to stay here the entire
no,
time.
you're perfect. That's great. Thank you very much. But do also wanted to make a quick note on history of colonization and that impact on our infrastructure. So the story is quite similar across the globe. Colonizers came, churches came, devastation, It was genocide of our people in many different ways, and we also were forced to, take on the infrastructures brought on by the governments. Historically, a lot of these were built anywhere from the 1940s to the 1970s. Were not necessarily made for the place-based environment we had. In my particular village, we had large clan houses that were built from the trees of the area, and they were built to withstand the environments we had. And we as people that were not necessarily nomadic, but had large amounts of lands, like if there was ever necessary need to expand, we were able to do so. There were some photos of Shishmaref shown where in those communities, those are houses built in the 1940s to 1960s. And they weren't built with the place-based traditional indigenous knowledge taken into role there. And so it's almost like a second coming of colonization in a lot of ways, because many indigenous people were forced to adapt and were forced to take on the infrastructures and homes of the colonizers. And now they're losing even those slowly, bit by bit, as the ocean carves in, as she does. And a quick story on that. So our colleague here showed a photo of a community where there was a large drop. When I was in my early 20s, there's this place in my village that is known where you would run and you would jump and you would slide down as a child, like almost like sand surfing, for lack of a better description. And I hadn't been home in 2 years. I had no idea a storm had come through and carved it into a cliff. And so I remember I was running to do that. And mid-jump in the air, I realized that my surf side had turned into a 20-foot cliff carved out by the storm. And I was like a cartoon running in the air when my brother grabbed the back of my jacket and hauled me back to the top of the cliff. And so our place-based knowledge is changing. And in a lot of these communities, it's important for researchers to have true relationships with us as we acknowledge that traditional indigenous knowledge is just as, if not even more so, adequate and necessary for finding the appropriate solutions. Whether a community finds it's important to move inward, whether it's important for certain solutions with what are they called? The winter storm walls that are built. And so I just want to acknowledge that, to thank you for the importance of researching something that impacts many of our communities, and do implore that anyone that works within our communities, please do so in a way that is culturally appropriate, that is in relationality and kinship with many of us, as we're willing and wanting to find solutions for the generations to come. So on thank and Tish.
Thank you. Yeah, so for those of you who are new here and haven't been here the past few hours, my name is Darcy Peter. I'm Koyukon and Gwich'in Athabaskan from the village of Beaver, Alaska. It's located about 4 miles below the Arctic Circle in the state of Alaska in the interior. So I'm not from a coastal community, but I did a lot of work in my earlier career stages with climate-induced relocation in particular Western Alaska. There are technically 15 in terms of the federal government in the U.S. communities that are threatened by coastal erosion and that are considering climate-induced relocation. The thing is, there are no funds for that because erosion is not considered a natural disaster in the United States because it is not a hurricane, it's not a tornado, it's not something that's very fast and very abrupt. It's something that's slow moving. That being said, like Maka, pointed out, one storm can take out an entire coastline. It can recede by, in my work, I've heard of one storm eroding 6 feet. We're going to have to redraw our borders. I mean, there's no other way to put it. This is something that needs the attention that it's due. If this was happening in New York City or New Jersey or LA or Tokyo, anywhere else in the world that has a high population of non-Indigenous people, then we would be finding funding in our back pockets. So this is something that I think really needs media attention. It needs to be talked about, and we need to find a solution for. So I'm privileged to be up on the stage here. I'm not from a coastal community, like I said. I've just done a lot of work with them, and with my close relations also, like Maka. Yeah, I'm just here to amplify the voices of the people who can't be here. So thank you.
So could you maybe the two of you comment on the housing? This is not something we talked about a lot here because it's a permafrost session, but we now saw and we see that in Greenland, we see that in Western Canada where I work, and in Russia particularly. There are different approaches to it. There are different approaches both in terms of architecture, but also in terms of legal approaches or policy. And so I'm wondering to see what is your experience on the ground in terms of housing. How many people live in houses? How long does it take to get a house, etc., etc. I think that works in a community impacted by such processes.
Sure. Can everyone hear me through the mask? Okay, excellent. I did want to, your question relates to our salmon, and while that might not make sense first off, in my village, there is a housing crisis because the salmon aren't coming back. That's tied to climate change. That's tied to ocean acidification. It's tied to warmth. For 100 to 200 to 300 years, my people have lived off salmon in our village with the Seatic River. The salmon was our economy and it was our subsistence. Without them coming back, many of our people are needing to leave my village and move out of our village to be able to support their families in some of the larger cities that are not as coastal. And within that, there's also the issue of infrastructure development funding, just as my friend Darcy here was talking about. And so back in my village, because I'm currently living in the city and pursuing my career, my family sold a parcel of our land to our tribe so that our tribe could build new infrastructure inland in the forest. And so they built a fourplex that they could put our elders in because our homes they're not withstanding the environment. And by homes, I mean the government built structures for us. And so we're working to adapt, we're working to build more inland, but there was also the other issues of salmon and economy and the other ways that climate change and colonization is affecting my people. It's tied together.
Yeah, it's hard to talk about housing without talking about food insecurity, which is a huge issue that I've touched on quite a bit today. But yeah, I mean, it's really hard to imagine what people are enduring in terms of climate change and permafrost thaw. Houses are falling into the ocean. I mean, it's plain and simple. There's no funding. I've seen people with four-wheelers or ATVs, all-terrain vehicles, trying to move entire houses because it's going to erode and there's a storm coming and there's no funding for them to either relocate or move their home inland more. And these are homes that 20 years ago were 30 feet away from the coastline, and now they're threatened to fall into the ocean. Graveyards are falling into the ocean. I mean, things that are unimaginable. Like if you've seen the photos that I've seen, you wouldn't believe what indigenous people are seeing along the coast of Alaska, and that includes Yakutat, I'm assuming. It just is really disheartening. I mean, we were asked to share a success story up here, and I can't think of one in terms of housing and infrastructure and things that the government has done to help with that. So in my community of Beaver, Alaska, it's in the interior, like I said, I mean, the Yukon River is eroding, and then there are issues with ocean acidification, like Maka said, with everything is just eroding, and there's nothing anybody can do, quote unquote. Their hands are tied, nobody can help, and it's really disheartening, and it's a really heavy line of work. I didn't have the mental capacity to stay in that line, but I applaud anybody who does, and I think that it's something that I'm really glad to be talking about, and I'm really grateful to share the stage with Maka, for sure.
Thank you. I'll ask the audience if they have some questions to ask to one of you guys. I just want to pick up on what you said, Darcy, about there is no funding. My experience is that there is funding, but it's usually used to fund the next assessment. And then there comes the next assessment on what to do and the next assessment on what to do. But this is not being acted upon. And then we keep doing assessments or like kind of a quantification of what should be done and how bad it is. But then the plan for action is actually not being implemented.
It sounds like COP26.
You're right.
It's sorry. I didn't mean to lose my temper. But I think that's why important we're here to do this work. It's important to work in relationality with us. It's important that many of us who are so close to these places and we're watching our great grandfather's grave, there's only so much that our hearts can take, which is important for the allyship and really intentional, meaningful allyship to do this work.
Good, thank you. I will. The three of us, I gathered, are very good at talking. So, like, I'm gonna let people ask questions if they want to the panelists. Anyone has a question?
In the meanwhile, I have a question about adaptation strategies, because you said that the only option is moving inland, right? And it is actually the only option, or there are also other options in terms of engineering or in terms of adaptation to this problem, to this issue? Thanks.
Thank you. So in Western Alaska, there are two options, technically. There's either protecting in place, which means you stay where you are and you try to protect against coastal erosion, or there's climate-induced relocation where you do move inland. That being said, both are a lot easier said than done. So when it comes to climate-induced relocation, you have to find a new site that's not near a river, which we're very tied to our rivers. There's a reason that indigenous people have villages along the river. It's because it's a lifeline. It provides food, water, shelter, everything that our people need to sustain ourselves. And they're asking us to choose a place away from the river. And then they have to do assessments, like our colleague said. Those take many, many, many years. There's no funding for that. A lot of it is volunteer work done by the community themselves, and that are very small and don't have the resources to do these assessments. And then but to even get to that step, they together as a community have to agree, yes, everybody here agrees to relocate. That is unfair completely. That should never be a question that we should have to ask ourselves. Like, imagine somebody goes to your house and they're like, hey, you have to move now. And you're like, what do you mean? I've like, my entire family's lived here. My grandparents, my great grandparents, like, this house has been passed down from generation to generation. And they just say, okay, well, we're going to tear your house down unless you move. So do you want to stay here and like lose your house that means so much to you, or do you want to relocate? Like, just to put it in very simple terms, like, we are very, very closely connected to our land. It should not be an option. So to even have that conversation is hugely emotionally taxing for Indigenous people. It's something that is very near and dear to my heart. I would never choose to leave my village and move to a new one. The thought of that is disgusting to me. So we have to have that conversation. Everybody has to agree. People who've been there since time immemorial, who've lived off the resources in this land, in this place for thousands of years. And then they have to look at a new site that they have no resources to look at and prove that it's sustainable enough and that it's strong enough to move to. And then it costs billions of dollars to build houses for people. So it's not a viable option. So that's the first one. That's to relocate. The second option is to protect in place. There's a mass decline in sea ice. We all know this. Climate change is real. There's no protection of the coast against storms. So with the mass decline in sea ice, there's nothing protecting the coast. So what do we have? We have man-made sandbags that we put along the coast, and we cross our fingers and hope that they don't burst and that our land doesn't erode. This isn't sustainable. Also not sustainable, not an option, because you can't protect against the elements. There's no force strong enough that can stop the elements in the natural disaster that is erosion. It's not a viable option. So that's our other one. We can't protect in place because there's no avoiding the erosion, and we can't relocate because there's such a huge emotional and spiritual, cultural, physical connection to a land. So this is a really hard topic to have. I'm glad we're having this conversation, but it's a lot more complicated than a lot of people think. It's a multifaceted problem, and there's no easy answer. So here you go.
Yeah, I don't really have much to add. I think you've created a beautiful description of the two of those. And the only metaphor I would draw would be it's been a few generations of grieving and mourning, a relationship to the land and a cultural practice that's been splintered. And then we're watching our first mother slowly disappear. And so it's a grieving process for many of us doing this work as well.
Yeah, thank you very much. I don't think we can spend too much time because the session is gonna, I think the next one at 4, Gustav, is that it? No? At 4:30. Also, we have plenty of time to talk 1 more hour. No, I'm kidding. We shouldn't do it so long. But the one thing you said about erosion is that indeed, I think for communities, some communities might be easier. I'm saying that with quotation mark, and for others, like the relocation, might be very far away. So there are also different kind of situations where you might find indeed a situation that might be fairly fast to agree on, but then the issues remain the funds. And to perform that relocation, even if you can agree on it. I understand. So I'm going to show later the data from the models that we have now for coastal erosion for the Arctic. That the first time we can put them out, and this is exploding and will explode as sea ice disappears, as you said. Waves are going to get higher. Sea level is rising. It can't go well. So there are increasing risks being faced here, and the funds that are required are going to be enormous. And I don't have an answer to provide, but this is very worrying. Do we have time for? We have time for another question. Go ahead, fire up, or like make advertising from one of your projects or whatever you want. Express your worries. No? No. Darcy, Maka, do you want to say the concluding words? And to be very honest, even though you were unable to see a success story, I see a lot of positive voices, or at least always signs of hope in what you're saying and a way forward.
I think the only note I'd make on that is in 2015, I helped found a program called the United States Arctic Youth Ambassador Program. It's based in Alaska and brings together a cohort of youth from all over the state. And they're ages 18 to 21. We do have one of the students with us today. My friend Ruth is sitting there in the back. And so we've brought one of those Arctic Youth Ambassadors here. And they create, well, let's see, they want to create new realities and hopes. And so it's important to invest in youth in these programs that are looking for new solutions or even culturally based solutions to the ways that our communities are being affected by climate change up in Alaska now.
Yeah, I can't say enough positive things about Maka and what she does. It's super, super inspiring and really important. Definitely talk with her after. She's amazing. Yeah, I guess my closing remark would be, yeah, this is tough. This is probably my, least favorite panel I've done today, just because I feel like we can't spend the amount of time on what needs to be talked about. And I feel really rushed in answering these questions, and I feel like I'm not doing it justice. So if you want to come talk to me after, please do. I have business cards. I'd love to chat more. Yeah, this has been interesting, but need to uplift the voices of the people who live in the communities more, who couldn't be here. So thank you.
If you want to take the time to voice this concern, you're like certainly free to do so. Right? We have plenty of time actually. So, okay, perfect. Well, we'll conclude here, I think, for this session, and we'll move on to the next one. So we have a break, and then we'll move, I think, 4 or 4:30. 4:30 for the next session, and we'll be happy to see you back again here in the pavilion. Bye-bye.